Hello and welcome. Today, we journey back 4.5 billion years to witness the birth of the Sun, the star that dominates our solar system. In the vast emptiness of space, there once drifted a giant cloud of gas and dust, known as a solar nebula. This cloud was mostly hydrogen and helium, with traces of heavier elements, the remnants of ancient exploded stars. Though it seems calm, this cloud was the raw material for an extraordinary event: the creation of a star. Over time, disturbances in space, like shock waves from nearby supernova, pressed parts of this cloud together. Gravity began to take hold, pulling gas and dust inward. The denser regions collapsed faster, drawing in more material, while the rest of the cloud started spinning slowly. At the very center of this collapsing cloud, matter began to clump together, forming what scientists call a protostar. This was the earliest stage of the Sunna-dense hot ball of gas, not yet shining, but growing heavier and hotter with each passing year. Around this growing protostar, the remaining gas and dust flattened into a spinning disk, the birthplace of future planets, moons, and other objects that would orbit the Sun. As the protostar continued to gather mass, pressure and temperature inside rose to unimaginable levels. Deep in its core, hydrogen atoms began to fuse into helium. This process, known as nuclear fusion, released an enormous amount of energy, and the protostar ignited, transforming into a star. This ignition marked the Sun's birthless self-sustaining fusion reaction that would shine for billions of years. During this time, the Sun's structure began to form. At the center lies the core, the hottest part, where fusion continues today at temperatures exceeding 15 million degrees Celsius. Surrounding the core is the radiative zone, where energy slowly moves outward by radiation, taking hundreds of thousands of years to pass through. Beyond this is the convective zone, where energy rises in massive currents of plasma, transporting heat to the surface, the photosphere. Above it stretches the chromosphere, followed by the transition zone, and finally the expansive corona, which reaches millions of miles into space. While the Sun formed, the leftover gas and dust in the surrounding disk began to collide and stick together, slowly forming planetesimals, which eventually grew into planets, moons, and other celestial bodies. Gravity from the Sun kept all this material in orbit, shaping the solar system into the structure we know today. The Sun's formation was not instantaneous. It took tens of millions of years for the protostar to stabilize and shine steadily. During this time, bursts of energy and strong solar winds blew away remaining gas, clearing the space around it. This clearing allowed the planets to take their paths without interference, and the Sun became the dominant gravitational force in the solar system. As a medium-sized star, the Sun is massive enough to control the orbits of planets, but only average compared to giants in the universe. Its diameter is about 1.4 million kilometers, and its mass is over 330,000 times that of Earth. Yet it is incredibly dense in its core, where matter is compressed to extreme levels, fueling the fusion reactions that provide light and energy. Over billions of years, the Sun's life continues, powered by the fusion of hydrogen into helium. However, like all stars, it will not last forever. In the distant future, the Sun will exhaust its hydrogen fuel. As fusion slows, the core will shrink and heat up, causing the outer layers to expand. The Sun will swell into a red giant, consuming the inner planets and dramatically changing the solar system. Eventually, the outer layers will drift away into space, forming a beautiful planetary nebula, while the remaining core cools and shrinks into a white dwarf, a dense, dim remnant of its former glory. Over billions more years, even this white dwarf will fade, eventually becoming a cold, dark black dwarf. The Sun's formation is a story of gravity, collapse, and fusion. From a diffuse cloud of gas and dust to a brilliant, burning star, the Sun set the stage for an entire solar system. Every planet, moon, and asteroid owes its existence to this remarkable process. Through the study of the Sun, scientists can understand not only our solar system, but also the formation of stars throughout the universe. The Sun may appear constant in the sky, but it is a dynamic, evolving star, a glowing reminder of the immense forces at work in the cosmos. And that is how the Sun was formed, a story billions of years in the making, a cosmic engine that continues to power everything in its orbit.